By 1835, New York City could not put out its own fires. Many of its wells had turned brackish or fouled. Its cisterns ran low. The rivers on either side of Manhattan were too salt to drink. Before a single reliable gallon could reach the island, an entire water system, dam, tunnel and reservoir, had to be built across 2 counties, using nothing but muscle, brick and gravity. The shortage was decades in the making. In 1798, a yellow fever outbreak led city officials to blame a stagnant pond at the island's centre. Cholera arrived in 1832 and killed thousands within weeks. In 1834, the city formed a board of water commissioners to find a source outside Manhattan, and in April 1835, voters approved its plan. 8 months later, the Great Fire of 1835 destroyed more than 600 buildings across 17 blocks. The cold had frozen the hydrants, and thick ice sealed off the East River. The site chosen for the new supply was the Croton River, 40 miles north in Westchester County. Major David B. Douglas laid out the first route and its engineering principles, but the water commissioners dismissed him within a year for incompetence. His replacement, John B. Jervis, had already built the Delaware and Hudson Canal and served as chief engineer of the Mohawk and Hudson Railroad before he ever touched an aqueduct. Jervis inherited Douglas's plans, finished the design, and divided the 41-mile route into short, contracted sections, each with its own crew and its own deadline. He would oversee nearly 4,000 labourers, most of them Irish immigrants, for the next 5 years. Construction began in May 1837 with a dam 6 miles up the Croton River, 250 feet wide, 55 feet high, backing the river into a reservoir 5 miles long. From the dam, the aqueduct ran south as a horseshoe-shaped brick tunnel, 8.5 feet high and 7.5 feet wide, laid on a stone foundation and buried under earth for almost its entire length. 16 tunnels cut through hills along the route, and more than 30 stone ventilator shafts, spaced roughly a mile apart, kept air moving through the line. Waste weirs let excess water escape during heavy rain. The aqueduct dropped so gradually in elevation across the distance that gravity alone carried the water 40 miles to the city. No pumps required. Masonry work at this scale left little room for error. In January 1841, before the aqueduct was finished, a sudden thaw sent a wall of meltwater down the Croton River. The earthen embankment of the new dam gave way. The flood tore out mills, bridges and buildings along the riverbanks below and killed a labourer named Michael Burke, whose body was found 3 miles downstream 3 days later. Damages ran to $700,000. The dam was rebuilt heavier and stronger, and construction continued. On the morning of June 22, 1842, water was released into the finished aqueduct. A 4-person boat, built for the occasion and named the Croton Maid, rowed the water south. It took 22 hours to reach the Harlem River. Guns fired a salute as the flow reached the receiving reservoir. 12 days later, the distributing reservoir at Murray Hill began to fill. The formal celebration came that October, a procession through City Hall Park on October 14, 1842, with President John Tyler in attendance and a fountain of Croton water rising into the air where the crowd could watch it fall. Not every mile could be built the same way. At the Harlem River, engineers first ran the water through iron pipes while a permanent crossing, High Bridge, was still under construction. It opened in 1848 as a 15-arch masonry span modelled on Roman aqueducts, and still stands today as the oldest surviving bridge in New York City. Its original pair of 36-inch pipes proved too small within 20 years, and a 90-inch pipe was added in 1861 to keep pace with the city's growth. At Manhattan Valley, the tunnel gave way to 4 parallel cast-iron pressure pipes buried beneath the streets. Near Ossining, the water crossed Sing Sing Kill on a masonry bridge faced with iron plate. The system was built to serve a city about the size New York had reached in the 1840s. It did not stay that size. Within a generation, population growth outpaced the aqueduct's 90 million-gallon daily capacity. New reservoirs were added piecemeal through the 1860s and 1870s, but they only delayed the shortfall. By the 1880s, city engineers were already planning a successor built to carry more than 3 times the volume. The difference between an adequate water system and a lasting one is not visible on opening day. It shows up in the decades after. The old Croton Aqueduct kept delivering water into Manhattan for well over a century in some sections, and its northern reaches, rebuilt and reopened in 1987, still supply the village of Ossining today. The new Croton Aqueduct, which opened in 1890 with triple the capacity and ran far deeper underground, operated alongside the original for decades rather than replacing it outright, and remains part of the city's water supply today. Both rest on the same principle Jervis established in 1837, a gravity-fed grade calculated once and trusted for generations. The Murray Hill Reservoir, built in an Egyptian revival style with 50-foot granite walls, was as much civic monument as infrastructure. An 18-foot promenade ran along its top, and New Yorkers walked it as a public park, looking out over a 4-acre artificial lake in the middle of Manhattan. For a city that had spent decades pleading for clean water, a reservoir built to be admired, not just used, was itself a form of civic pride. Bathtubs and indoor plumbing spread quickly through wealthier households in the years that followed, and public bathhouses opened for residents who had none. The city that had once carried water by the bucket now measured it in the millions of gallons. By the 1890s, the old Croton Aqueduct had been overtaken by the very growth it had made possible. The Murray Hill Reservoir was drained and demolished in 1899 to make way for the New York Public Library. The receiving reservoir on York Hill followed in 1930, replaced by the Great Lawn in Central Park. The aqueduct itself carried city water until 1955, not because the engineering had failed, but because New York had simply outgrown it. Long before pumps and pressurized mains became standard, New York's water depended on the shape of a hillside and the patience of gravity. The tunnel that carried it required no fuel and no machinery, only a grade calculated correctly across 41 miles, and thousands of hands willing to lay brick to that measurement, mile after mile. What survives of it today is preserved mostly as a walking trail through Westchester County, the old Croton Aqueduct State Historic Park. What it made possible was a city that no longer had to fear its own thirst. These systems shaped the world quietly. If you'd like to see more of them preserved, consider subscribing and tell us which forgotten system we should uncover next.